Hello everyone. Today I'm gonna talk about the third element of the the network foundation protection. It's a data plane. So data plane it's when a router or a switch is forwarding frames or packets on behalf of others. So if you send in packets, for example, from uh, an internal network outside to an outside network uh, or an internet device. So the computer sent the packet to the switch. Switch is forwarding the packet to the router, and a router, it's a data plane actually. It's actually moving or forwarding, packets uh, to another devices. So they are basically forwarding from a device to device. So it's like transit packets. Uh, Transit packets is a packet that somebody would send. It's going to somewhere else, but it's not going to the IP address of the router or switch, but it's only going through these devices to reach the destination. So the frames they are forwarded from the switch and the layer 2 switch, and the packets are forwarded by layer 3 and the router. So this is the example where is the data plane or data function means. So the how traffic will be forwarded. All traffic, all the traffic will be forwarded through sessions like TCP session or UDP session. And there is channels as well like TCP channels. So TCP, HTTPS, DNS, and all of the traffic that are being forwarded between these devices or hosts. So how now we're going to talk about how we can control the data plane or data function. So for security, how we're going to be controlling this data to be flowing through our devices in the network. We have to put some limitations and restrictions by implementing, for example, the ACL, ACLs, the access control list for the IP version 4, IP version 6. So TCP spanning tree protocol safeguards also could be helpful to protect those packets. So many people sometimes get an attack in the spanning tree protocol by sending from the switch some PDUs, advertising PDUs. Doesn't it's not a real packets being sent from a switch. It's just someone's plugs a switch into the network, and he keeps sending the TCP packets through the PDUs to all the network. So we can do like the implement the security like PVDU card and uh, and some other security tools to protect our packets. So if a user inside the company starts sending BPDUs, so this videos actually should be sent only by spanning spanning tree protocol device. So if we see, for example, the safeguard or the BPDU guard, what it does is when he sees that there is a videos advertisements coming from this port, will shut down the port. And if you shut down this port, you can always bring this port back again anytime you would like, or you can even automate that to be up for the port to be up anytime after it has been shut down, after 1 minute, 1 hour, 5 minutes, whatever you want it to be back up again. So this way we can make sure that no one can spoof our Spanish tree and cause problems. So tools like root guard for antenna switch connections, PPDU guard to lock down ports and, to save make our network safe. So sometimes there is a users that internal users that they're trying to send like tens of hundreds or millions of frames into the network. So if he wants to send like 10 million or 1 million frames into the network, he can go ahead and send them. We cannot stop him, to send any frames he wants. He can send as much data as he wants. But if he sent 10 million frames, that means millions of different source IP addresses. That's kind of like yeah, that's kind of bad for the network. Will use all resources on the switch, so switch might go down for some reason, because it's learning a lot of MAC addresses, millions of MAC addresses, and actually the switch cannot handle millions of MAC addresses. But when he reach when someone spoof the switch, and the switch reach the maximum MAC addresses, he can learn what happened is the switch starts advertising any frames, broadcast all the frames. So if the MAC addresses, if the switch can memorize only, like for example, 50,000 or 10,000 MAC addresses, and if sending like millions of MAC addresses in, we have basically the MAC address table full, completely full. It's first in, so the switch will be using the technique first in, first out. So the switch will not know where is everybody and where each device is. So the switch this way will just start flooding the frames to all ports on the switch. So that's the switch. What it does actually, and he doesn't know the switch doesn't know the MAC address of the device. Any device wants to reach, it will just send the broadcast through all of the ports on the switch. So if the eavesdropper is flooding the frames in the switch, so all of the frames will be sent to to the frame, so that you can broadcast. So if you is dropping on the network, it will be easy for any hacker or attacker uh, to you know, to check all of the frames are coming through or going from switch to other places, because all the frames have been advertised in all of the ports. So if you are using some kind of tools to attack the network or to sniff password or the telnet sessions for the routers or devices, the attacker will get a copy of all of the frames going through the network. So that's why we have to use the port security. In the port security, we can give a limit to each port to advertise, to learn just specific or few MAC addresses, like 1 or 2 MAC addresses. This way we can have control over the switch. So if the switch receives more than 2 MAC addresses, will automatically shut down. So we cannot use that port on the switch anymore. So if we are using, for example, voice IP or voice over IP frames, that will be another thing. We can also use a firewall, or we can use also the IDS or IPS, intrusion detection system, or intrusion protection system. Yeah. So those systems you can use for the detection system, intrusion detection system. We can detect all of the, the, the any frames that are suspicious in the network. So we can with IDS we can only detect them, but with IPS we can uh, stop those frames, those packets from going through our network. And IDS and IPS we can protect. We have also a host-based IPS and host-based IDS.